Alright, here's our next lesson. This is lesson 1.6 in your book. This is called classifying polygons. So we're going to start with defining this word polygon. We're going to use sides and vertex along there. We've got a couple other terms later on as well. And then a couple examples at the very end and we'll be done. So a polygon. A polygon is a two-dimensional shape. If I can spell dimensional, it would help. A two-dimensional shape. Sometimes that's referred to as a plane figure, P-L-A-N-E figure. Just means it can lie in a plane. All right, remember planes are two-dimensional, so that makes sense. All right, it's a two-dimensional shape. Let's see, what else is important? Straight sides, so no curves. Okay, no gaps. All right, the sides have to connect to each other. Alright, let's see, no overlapping of sides. The technical way to say this, I'm not going to write it down, but the technical way to say there's no overlapping of sides is that anytime a side intersects another side, segments, they're made up of segments, anytime a segment intersects another segment, it has to be at the end point. Okay, so if they intersect anywhere other than their endpoints, doesn't count as a polygon. Alright, let's see if I've got everything we need. Two-dimensional shape, straight sides, no gaps, no overlapping sides. Yep, pretty good. So sides. I already kind of mentioned this. These are just segments. Okay. They have to intersect all the other segments only at endpoints. That's important. Okay. Vertex, the plural for that is vertices. Okay, it's kind of a different spelling. It's not vertexes. Vertices, these are points where sides or segments meet. Okay, remember, again, it has to be at the endpoints. Okay, they're basically the corner points of the polygon. A polygon is always going to have the same exact number of sides as it does vertices. Think through simple things like a triangle. It's got 3 sides, 3 vertices. Rectangle, 4 sides, 4 vertices, always works that way. Okay, here's a couple pictures. We're going to talk about whether or not these are polygons. So this one, is it a polygon? Remember, you can answer these questions out loud at home if you want. It's never a problem if you get them wrong. Getting things wrong is a chance to learn. Okay, this one is not a polygon. Remember, right here we said no gaps. Okay, so there's a big gap here. Another way to say this no gaps thing is it has to be a closed figure. Alright, closed figure. This is not closed. Okay? This one. Is it a polygon? Nope. Okay? Straight sides. Remember, the sides are segments. Segments have to be straight. This is curved. Okay, that doesn't count. This one. Some people get this one confused. Is this a polygon? This is not a polygon. Remember, no overlapping of sides. Sides can only intersect other sides at their endpoints. Right here, we have this side and this side intersecting somewhere other than the endpoint. Okay, so none of these are polygons. That's a polygon. Straight sides, I know it looks a little bit curved here, that's just because I didn't use a straight edge, but straight sides, closed, two-dimensional, all right, connects only at the endpoints, that's a polygon. That's a four-sided polygon. Quadrilateral, should be a term you recognize. We're going to talk about all the names later on. Okay, there's our first page. Let's jump to our second page. We really only have 2 terms on this page, but I'm going to give you 2 definitions for each term, convex and concave, and the definitions are a little bit lengthy. I'll draw a picture as well so you can kind of see what's going on. You have to know one of the 2 definitions. I don't care which one. You pick one, pick whichever one you like better. Right, and then just know that one and know how to use it. So basically I'll ask you, is this shape convex or concave? Explain. As long as you use one of the definitions in your explanation, you're fine. Convex. If you extend all of the sides so that they become lines. Remember, the sides are segments originally. If you extend all the sides so that they become lines, then at least 2 of the sides will enter into the polygon. Oh, no, that's concave. Back up it. Then none, I apologize, none of the sides will enter into the polygon. I got ahead of myself there. None of the sides will enter into the polygon. Okay, sorry about that. If you extend all the sides so that they become lines, none of the sides will enter into the polygon. Let me show you what that looks like. So I have a 5-sided polygon over here. This one is convex. If I take this side right here and I extend it out left and right so it becomes a line, looks like that and that, that line does not go inside the polygon at all. Okay, do the same thing here, up and down, does not go inside. This one over here on the far left, up and down again, does not go inside. Okay, this one here kind of diagonally, down to the left, up to the right, does not go inside the polygon. And finally this one right here, extending it out, does not go inside the polygon. So none of these sides, when I extended them to become lines, entered into the original polygon. It means it's convex. Second way, okay, once again, if you like this definition, great, go with it. If you prefer the second definition, go with it. You just have to know one of them, okay? All right, so if you pick any 2 points inside the polygon and connect them with a segment, make sure you say segment, don't say line here. Line would not work, it has to be a segment. If you pick any 2 points inside the polygon and connect them with a segment, then the segment cannot go outside the polygon. So our first definition talked about not going inside the polygon, now we're going to talk about not going outside the polygon. Okay, so if you pick any 2 points inside the polygon and connect them with a segment, then the segment cannot go outside the polygon. Alright, let's take a look at that. I'm going to draw basically the same shape if I can draw it pretty similar. Okay, something like that. Okay, once again, convex shape. Okay, pick any 2 points, 1, 2. They're already inside the polygon, connect them with a segment. That segment had to stay inside the polygon. Pick another 2 points if you want. 1, 2, way up here, connect. Segment is still inside the polygon. Okay, there's no place you can pick any 2 points here, here, whatever, and connect them and have it go outside. The only way that would happen if it's curved, that's not a segment, not going to work. Okay, that's convex. Concave, first part's going to stay the same for both, the if part. Okay, so if you extend all of the sides so that they become lines, then here's what I tried to say before. At least 2 of the sides will enter into the polygon. Remember last time I messed that up and I said that one on the last definition. Sorry, that wasn't in the frame the whole time. So if you extend all the sides so that they become lines, then at least 2 of the sides will enter into the polygon. So let's look at a concave shape, something like this. Okay, so if I give you a shape like this and I say, is it convex or concave? You're like, oh, it's concave. Like one section kind of like, sort of like caves in. Okay, if that was on a quiz or a test, you might get 1 point out of 5 for that question. Yeah, you got it right, it's concave. Do you absolutely know why? No, it's not anywhere close to the definition. Okay, extend all the sides. So we're going to extend this one right and left. We're going to extend this one over here up and down. Okay. We're going to also extend this one up and down. Okay. So far none of them have gone inside. Still technically convex until I extend this one right here, and right there we have a problem. Went inside the polygon. Okay. When I do this one, we're going to have the same issue. Up there is fine, down here is not. So those 2 spots right there, where those lines went inside the polygon, that's what makes it concave. Okay? It can be more than 2. It can never be exactly 1. It's impossible. Okay, so it's either 0 or it's at least 2. All right, you could have 10, you could have 3, all right, you could have 4, whatever, okay? But at least 2, that's all that matters. Okay, let's go to the other definition. Remember, it's going to start the same way as this one, if you pick any 2 points, okay? If you pick any 2 points inside the polygon and connect them with a segment. Remember, it's got to be a segment. Okay, pick any 2 points. Sorry, I keep getting this out of the frame while I'm writing it. If you pick any 2 points inside the polygon and connect them with a segment, then the segment, remember last time the segment cannot go outside the polygon. We're not going to change it down here to say the segment has to. Okay, it doesn't. The segment can go outside the polygon. Okay, I'm going to show you some that do, some that don't. Okay, I'm going to draw the same concave shape. Okay, that kind of M looking thing, and then we'll just connect it at the bottom to make it actually a polygon. Remember, without connecting it, it's not a polygon, it's got a gap in it. Alright, pick any 2 points inside the polygon. 1, 2, connect them with a segment. Okay, that segment did not go outside, so that's why we aren't going to say here the segment has to. It doesn't. This segment does not go outside the polygon. Okay, try it again. Pick one here, pick one down here. Connect them. Still didn't go outside. Can you find a place where if you put 2 points and connected them with a segment, that segment would go outside the polygon? Think about that for a second. If you can draw it on your paper real quick, do that while I'm kind of rambling for a minute or two, letting you think. Alright, what do you think? Have you got it figured out? Start up here again. Okay, right? Start up here. Connect those with a segment, and right there, where I put that arrow, you got that little section that goes outside the polygon. That makes it concave by this definition. Okay? Convex and concave. You need to know one of those 2 definitions for each one. Most people prefer to either go with this one for both or the second one for both. Very few people want to do one for one and a different one for the other one. I don't really care what you do, as long as you know one definition for each one. And you need to know it well. Okay, let's go next. I'm going to get these 3 terms. Equilateral, you probably already know that term. Equiangular, if you know equilateral, you can probably figure that one out. Lots of people struggle with that one. Maybe they remember it, maybe they don't. Maybe they've never heard of it. A lot of people forget this one during the year. I put this on a quiz test, whatever, later on in the year, and I get lots of people get it wrong. You've got to know this word later on in the year as well. They're all important throughout the whole year, but people tend to forget this one the most. Okay, equilateral. Lateral means sides. Equal, that's pretty simple. Equal sides. Very simple. If I haven't mentioned this in class already, I'll mention it again at times. If you ever get the chance to learn Latin, learn it. It helps you figure out definitions all the time. This just means equal sides. So this is a polygon with all sides being equal or congruent. Okay, congruent sides. So you probably know a shape that has that. All right. Equilateral triangle obviously is one of them, but it could be a rhombus. Okay, you guys remember a rhombus? Right? Okay, something like that. All 4 sides are the same length. We usually put marks on it to show that they're the same, so something like that. Okay, equilateral. Equiangular, well, you can probably figure that out. Lateral obviously means sides. Angular, yeah, it means angles. Not complicated. A polygon with all angles being equal. Okay, congruent angles. Okay, a rectangle is a pretty good example of this one. Every angle is 90 degrees. Remember when it's 90, we usually kind of use that little box there. All right. If we had maybe a triangle, we would just put a mark on it. Let me show you, all right, what that mark might look like. So a curve for an angle, all you do is match the same curve. The same curve. If we wanted to say that one of the angles was different, we'd put like a double curve on one of them. So the two that have the single curve are congruent, and the one with the double curve is different. All right, these all have the same exact curve, so they're all equal, congruent. Okay, so either one of those is considered equiangular. Let's go regular. This is both equilateral and equiangular. Okay, the word regular has a very special meaning in geometry. Equilateral and equiangular. It's not normal, typical. It's not the, how was school today? Oh, it was just a regular old school day. All right, it's not that definition. It's a very specific definition. You have to know it. Okay, equilateral and equiangular. Probably the most common one that you know that is regular would be a square. Okay, so we've got 4 equal sides. Mark them again. All right, we got 4 equal angles, 4 right angles for a square, so we'll use the little box for it, and there you go. All right, you might have a, I can't draw it real well, but like a stop sign, okay, regular octagon, okay, so I'll try to get it drawn as best I can. Sometimes it's hard to get the sides equal, and we'll do the best we can. I don't expect you to be perfect with it, but as long as you put in these marks on there and it looks pretty close to congruent, you're fine. Okay? And then we would put the same exact angle measure on every single angle. Okay, so I got 8 sides, 8 angles. Remember earlier in the lesson I told you it always has to have the same number of sides and angles. So something like that. You could do a regular hexagon. Those ones aren't overly complicated. Okay? Really any shape. Alright, let's talk about all those names. I've mentioned some of them already. You probably know a lot of these names already. There's going to be a few that are a little weird that you might not have ever heard of. 3, you probably know that one, right? Triangle. 4, don't get confused and put rectangle or square or rhombus. Those are all different versions of quadrilaterals. Quad means side, 4, lateral means sides. Okay, quadrilateral. Okay, once again, if you know Latin, makes it easy. Quad, 4, lateral side, 4 sides. 5, if you've been to Washington, D.C., you've probably seen a very famous building that's 5-sided called the Pentagon. Right? Penta means 5. There's other things that start with penta that mean 5. All right, but this is probably the most famous one, is that building in Washington, D.C. All right, 6. Most of you probably know 6. I already mentioned it. Hexagon. 7. That's one that a lot of people don't know. Heptagon. Heptagon. Okay. 8. Most of you know that one. Stop sign. I already mentioned that. Octagon. In the town I grew up in, it's called Watertown, Wisconsin. It's actually a very famous building called the Octagon House. It's an 8-sided house, like 3 or 4 stories tall. Built a very, very long time ago. So pretty cool design from quite a while ago. Number 9, this is one probably a lot of you don't know. Non-agon. Okay, non-agon. Right, that non prefix has the idea of 9. 10 you might know, because 10's that Latin word again that we use pretty frequently, like decade, or maybe if you're doing the decimal system, the metric system, a decameter, or even a decimeter. Very similar in spelling. One is D-E-C-A, one is D-E-C-I. This one is D-E-C-A, decagon. Okay. 11, that's one you probably don't know. It's a pretty rare one. Don't see it a whole lot. Basically what we do is we kind of use the Latin, deca. I think the other part might be Latin too, but it's definitely, you can use Spanish to help you out. So we're going to start with the deca idea. Okay, that's 10. Okay, then all we got to do is add 1 to it. So uno in Spanish is 1. We kind of drop the O off. So we just call it an un decagon. So that's 1, 10. 1 and 10 giving me 11. So if you use that idea of 1 and 10 to go to the 12, we're going to go 2 and 10. So think through that. What do you think? 2, Spanish class. Deca, we already know for 10, so dos, right? Once again, we dropped the O off, so we're going to drop the S off, so dodecagon. So, what do you think for 13? Most people would answer tre decagon, right? Uno, dos, tres. All right, tridecagon, in geometry we kind of get lazy after a while, to be honest with you. We just go, enough of that, 13 gone. Okay, so you keep coming down the line, whatever, you get to 27 or whatever, and you're like, 27 gone. Okay, once we get past 12, we typically just use the numbers. There are a few that have special names. I'm not going to make you know any of them past 12. All right, you definitely should know them up to 12. All right, remember, you can't have one or two sides, because it wouldn't close. Okay, so you need to know 3 through 12. All right, almost done. Basically, I have two examples. Square. Remember, a square is a regular quadrilateral, so we're going to solve for x. All right, copy this down. If you want to solve it real quick, all right, you can pause. Remember, I'm not going to pause here and wait for 5 minutes for you guys to do it, but hit pause, copy it down, solve it, come back, check your answer. All right, you should have hit pause, you should have copied it down, and you should have tried it on your own. It's also a really, really good idea once you solve for x to plug it back in and see if you got the right answer. Some of you don't do that very well. Common mistake on this one would be to do a little bit of algebra wrong and get x equals 3. Okay, if you actually get x equals 3, 3 times 3 is 9, 9 plus 7 is 16, 5 times 3 is 15, and 15 minus 13 is 2. 16 and 2 doesn't make any sense for a square, so we don't want to do that. So 3x plus 7 equals 5x minus 13. I get a lot of people who aren't sure, should I put a plus in here, should I put an equals in here? Remember, equal sides, that's what regular means, equal sides, equal angles. All right, there are times where we're going to add the sides up. Okay, this is not one of them. We're going to subtract 3x from both sides. We get 2x. This cancels, I get my 7, I get my minus 13. I'm going to add 13. Add 13. Some of you might be wondering, how in the world did you get a 3 for an answer? Some people get a 6 somewhere along the way with a 13 and the 7. You should be getting a 20. Okay, 13 minus 7 does give me 6. Okay, these canceled out, so we get 2x equals 20. We're going to divide by that 2 and get x equals 10. We're going to double check that real quick. 3 times 10 is 30. 30 plus 7 is 37. 5 times 10, 50. 50 minus 13 is 37. Our answer makes sense. Remember, we're going to get in the habit of putting labels on things. If this had said inches, we're going to put inches over here. If it says feet, we're going to put feet, obviously. If it doesn't have a label at all, we're going to put units. Okay, 10 units. All right, last example and we're done. Copy this one down. All right, regular hexagon and an equilateral pentagon have the same perimeter. The hexagon has one side that is 15 inches long, so find one side of the pentagon. All right, copy that down, hit pause, and solve it, and then come back and check your work. All right, you should have copied it down, you should have hit pause, done all the work. Let's see what you got. So, same perimeter, that's important, okay? Regular, that's important. Hexagon is important, equilateral is important, pentagon is important. So, you can draw a picture if you want, you don't really need to. All right, how do we find perimeter? Okay, that's important. How do we find perimeter? We add all the sides up. So let's start with this hexagon. I know it's got 6 sides. Regular means all the sides are the same, and one of them is 15. So all 6 sides are 15. So you can do 15 plus 15 a bunch of times, or a lot faster. You can just do 15 times 6. It gives me 90 inches. So the perimeter of the hexagon is 90 inches. All right, well, now I need to go find one side of the pentagon. All right, it's equilateral. Again, all the sides are congruent. Pentagon's got 5 sides. So I need 5 sides to get me to that 90 inches. So if I don't know what that side is, all right, 5x equals 90. We divide by the 5 and we get x equals 18. Once again, we need a label, so we're going to put inches on that. And that is one side of the pentagon. Remember, if you have any questions, jot yourself a little note in your notes. Ask me in class. Make sure you know what you're doing. That is the end of this lesson.